Let us now look at our final recording. That was site number 7. I'm going to click on it. This was a recording with increased jitter and blocking. I'm going to maximize the window. My triggering potential is very stable. It has the same waveform. My window is in correct position, but my stop window is quite short. So this is where I'm going to increase its duration like this. You will notice there are 3 different colors of traces in this signal. We have the white traces that actually have an action potential pair, so these are used for jitter analysis. We have a blue trace over here. This one had a very high interpotential interval and therefore it was excluded from analysis using statistical principles. And finally we have red traces. Notice that they cross only the first window but not the second window. The second potential is missing completely. This is where we had blocking. Let's look at the result table. We had 149 discharges. The jitter was significantly increased, 189 microseconds, and 62 potentials out of 149 blocked. When blocking occurs, we must be careful and make sure it is not a technical problem. This is where review of traces is quite important. So I'm going to go into the review mode, and now we can see 5 traces at a time over here, and we can scroll through them to look at the jitter and blocking. If we want, we can superimpose the traces. That way we can be absolutely sure that the potentials that are triggering are constant in shape like this. So this is definitely not a problem with mistrigger. I'm going to unsuperimpose these traces. I'm also going to make this window large. When we look at the distribution of interpotential intervals, we can see a very large scatter. So this is consistent with increased jitter. And one data point has been thrown out. It is shown in light blue color. Let's say I want to look at this waveform. Why does it have such long interval? You can click on it and it brings the trace into the window and shows in yellow color. It has a very long interval. You can see it in the bottom window. You can also see it in the top window. Well, what about this data point that has got very short interval? So let me click on the data point, and now you can see the short interval. So this relationship between the interpotential interval plot and the traces makes it very easy to identify traces that may have questionable quality. So you can look at very long intervals, very short intervals very quickly. If I wanted to exclude this trace from analysis, I can click on it. It is now excluded. Notice the blue color over here. If I want to exclude this trace, click on it, it became blue in color. I can re-include the traces in analysis and so forth. So all of this capability that was previously available in the software is still preserved and perhaps a little bit enhanced by the link between the interpotential interval and the data point. I'm going to get out of the review mode, but before that let me do one more thing. Here is a data point. I know that this belongs to the motor unit. This is not an artifact. Perhaps I want to include this in my results. I can click on the window, bring it up. It is now included in my analysis, and notice it's changed the color from light blue to white. So this is the flexibility that is offered in the new software version. Let me get out of the review mode. The system will automatically throw out blocks when the jitter is less than 60 microseconds. Blocking occurs when the jitter is usually 100 microseconds or more. So we do have an area where the jitter is between 60 and 100, where we may have increased jitter without blocking. Now imagine that if we had some technical problems, we do want to throw out those technical blocks. The user can override the blocks detected by the machine. So if I believe that this recording does not have blocks, I can click on the function key F6 and notice that it removed all the traces in the red color from here. If I want to re-include those blocks, I will click on the block function key, and now those traces are back into the analysis. So this is another powerful control to throw away spurious triggers when the jitter is slightly increased. The last feature that I want to demonstrate, it is not used very often, but it is related to the selection of the rising or falling edge of the potential for jitter analysis. We usually use the rising edge because that's a sharper portion of the waveform. But if the interpotential interval is short, sometimes we may want to use a falling edge. Some people prefer to use the peak trigger. Both modalities are available. But here is a quick exercise. Right now I'm using the rising edge for jitter measurement. If I want to use the falling edge, I can click on this icon, which is the jitter cursor setup. And the first window is on the rising edge. The second is on the rising edge. I'm going to change it to the falling edge. Click on OK. And now my jitter is 188. I will go back to the rising edge. And it is 189. Really didn't make much of a difference. Most often we don't use the falling edge, but that option is still available. So we have now reviewed all of our recordings. We have looked at different features. Let us look at the summary results.